Alright, for the homework answers, you should have set it up like this. I need my other pointer. There we go. Have an X, a Y, and then the hypotenuse is this. Area formula, and the perimeter is 280. For the perimeter, do not add Y in there because you don't need Y. It's up against a river, so you only need this side and this one. You're going to end up setting this equal to this and solve for Y. So over here, there it is, set equal to 280. Move the X over and then square both sides so you can get rid of the radical sign. That means you free up these two here, but over here you have to do multiplication. This times itself will give you this. Notice you have an X squared on both sides, so they cancel out. And you're going to be left with Y squared equals 78,400 minus 560X, but you need the square root of both sides to free up the Y. And you'll end up with this on the right side. So over here, you're going to have to plug in this value you found for Y into the Y spot of the area formula. And then you need to go through and find the derivative. So when you do that, you're going to need this half broken up. You want it outside of everything. And then use the product rule with this as one item and this as one item. So if you follow a pattern, you can't go wrong. If you want to, you start with this item just as it is and multiply it by the derivative of the other item. And then do plus and reverse that process. You want this item by itself as it is, but then times the derivative of the other item. And we're going to practice that more today. But then you go through and find the derivative of each one. On this one here, you're using the chain rule. What's under the radical sign, keep it on top and find the derivative of that. And then move this item to the bottom and multiply by 2. Over here, the derivative is 1. So it's just gone. So back down to here, once you need the derivative of this, you break it up. The derivative of a difference is the difference of the derivatives. The derivative of a difference is the difference of the derivatives. And everything else stays the same. This will boil down on top to this, which you can simplify with this 2 on the bottom. Alright, so there it was. The 2 was here, so we simplified it with what was on top to get the 280x. And then distribute through the 1/2. That's going to knock this down to 140. Don't forget the negative sign. And then over here you have a 2 on the bottom. Alright, so what I did here is I bumped over this term which was negative on this side, moved it to the right, made it positive. Cross multiplied here, and you'll get rid of the radical signs because it has the same expression under each. Cross multiply here, that's where that goes. This is what you get from this. Move this to the other side, add it, and then divide. You should come up with 93 1/3. And then from that point, you need to plug this back in to that perimeter formula you had where you had y set equal off to itself and equal to an expression. Alright, any questions about that problem? If you had, page 1 people, if you had those answers, you can come on up. Klein had it. Bentley. Okay, page 2, folks. Yeah. Yeah. All right. If you can make it through this stuff between now and the end of the year, you'll be doing fine in college. when you get to college, you have to remember that it's no longer high school. I once went to high school with a guy that went to college, and for the first 3 weeks he thought he was going to be the class clown of every college class he had. And after 3 weeks, all of his professors just scratched his name off the list and he was done. He's worked at AutoZone for the last 23 years. And that's a shame because he was smart. And there's nothing wrong with working at AutoZone, but not for 23 years when you had the opportunity to go to college and do something. It was more important to him to be funny and get laughs than it was to actually do something important. But I think you'll do much better than he did. All right, here we go. To use calculus to solve optimization problems. All right, here's the first example. There's the product rule, and I've boiled this down as simple as I can. You have a function, and the function consists of two terms multiplied together, and we'll call them A and B. In order to use the product rule, you want A as it is multiplied by the derivative of B, and then plus B as it is times the derivative of A. So it's just like a reverse process there from one side to the other. So here's a problem we can try. I need a smaller marker. There we go. So if we want to find y prime, we can start with x to the third plus 7x and then minus 1 as it is. And then you're going to multiply that by the derivative with respect to x of 5x plus 2. And then on the other side, you want to start with the second term as it is, the one you just wrote. So we'll have 5x plus 2, and then times the derivative with respect to x of x to the third plus 7x minus 1. And from there you go find the derivatives where you need to. So on the first part, I'll switch colors each time so it'll be a little easier to see. This stays the same, but you need the derivative of what's over beside it. The derivative of 5x squared is simply 5. Or not 5x squared, but 5x plus 2. So that's 5. And then on the other side, 5x plus 2 stays the same. And now you need the derivative of x cubed plus 7x minus 1. And that derivative is 3x squared and then plus 7. Now from there you just have to simplify. You're going to end up with a 5x cubed plus 35x minus 5. And then over here you have to do a FOIL thing here. So it's going to be 5x times 3x squared is 15x cubed. And then 35x. Now move to the 2 for multiplying and get 6x squared plus 14. Now go back and simplify. 5x cubed, 15x cubed is 20x cubed. And we have a square, 6x squared. And for your x terms, we have a 35x and a 35x. That would be 70x. And then minus 5 plus 14 would be 9. Example 2. In this one, you have x to the negative 2 times the quantity 4 plus 3x to the negative 3. Use the product rule and come up with y to the first, or not y to the first, but y prime. And we'll start with x to the negative 2 and multiply it by the derivative with respect to x of 4 plus 3x to the negative 3 power. And then reverse this process on the other side. You want to start with 4 plus 3x to the negative third as it is, and multiply it by the derivative with respect to x of x to the negative 2. That's the setup. It's just the a, b prime plus b prime a. You just alternate after the plus sign. Now this gets interesting pretty soon. Not with this part, because you just leave that the same, but with inside here you need the derivative of 4 plus 3x to the negative third. You can't do the derivative of 3x to the negative third like you do the ones with a positive derivative, because you have to remember that a negative exponent means that it's really supposed to be in the denominator as a positive exponent. And if you remember back when we did derivatives that were in the denominator, you didn't take 1 away from the exponent. You added 1 to it and multiplied the top by the former exponent. So that's what you have to do here. But the derivative of 4 is just 0, so it's gone. But notice that you have x to the negative third. That's going to now become x to the negative fourth, because you're adding 1 to it. And then you multiply the top, where you're already at, by the former exponent. So that former exponent ends up being a negative 3. So you go negative 9 at that point. Alright. And then we go plus 4 plus 3x to the negative 3 stays the same, but now you need the derivative with respect to x of x to the negative 2. So you add 1, actually taking 1 away in this case, make it a negative 3, and then you multiply by the negative 2 out to the left of it. And then go back and simplify. So we have x to the negative 2 times negative 9x to the negative 4. So clearly the negative 9 is going to stay, but x to the negative 2 times x to the negative 4 is x to the negative what? Yeah. Then over on the other side, you have to multiply 2x, negative 2x to the negative third by each of these items there. So you'll have a negative, a rare case where I write plus a negative 8 x to the negative third, and then minus 6x to the negative sixth. Now we don't want to leave these items where they're at. We want to simplify. First, you have this and this. That would give me a negative 15 x to the negative sixth. And then minus, I just wiped out most of that stuff. I don't know why. Oh, I hit the back button when I was recording. But thankfully it still kept what we need. So you're going to have a minus. I tried to go back and wipe out that mark there. But minus 8 to the negative third. And then simplify that. I may have to squeeze this in here really tight, so I'll give it my best shot. Make that a negative 15 over x to the sixth, and then minus 8 over x to the third. The solution for this one, for y prime, start out with the quantity of 4x squared minus 2x as it is, and multiply by the derivative with respect to x of 3x minus 2. And then plus 3x minus 2 as it is, times the quantity of the derivative with respect to x of 4x squared minus 2x. So we'll go back through here and simplify. This first part will stay the same, but the second one, the derivative of this quantity is simply 3. And then this quantity will stay the same. The derivative of this quantity is 8x minus 2. So you have to do some expanding here. If you multiply by 3, you get 12x squared minus 6x. And then with this, you're going to get 24x squared minus 6x minus 16x plus 4. And now you have to simplify. 12x squared and 24x squared is 36x squared. And then minus 6 is minus 12. minus 16 is minus 28x, and then plus 4. So we're looking for y prime. We're going to start with 2x to the negative third as it is. Multiply by the derivative with respect to x of 5 minus 4x to the negative 2. And then plus the quantity of 5 minus 4x to the negative 2 times the derivative with respect to x of 2x to the negative third power. Alright, so we have some simplifying to do here. This will stay the same. And then here you're going to have a derivative. Of course, this part is 0. And then you want to increase the exponent. Actually, it's lessening it, but I say increase number-wise by 1. And then that former exponent goes out in front, the negative 2, and you're going to multiply it with the minus 4 to get a positive 8. Now we'll go over here and keep this item the way it is. And then the derivative of 2x to the negative third is going to be negative 6x to the negative fourth. Now we have to do some multiplication here. I'll change to black, and that should be a prime. There we go. Multiply here. If you're going to multiply here, you end up with 16x to the what power? Yeah, I just left out, that mark didn't show up for some reason, or I just left it out, but that should be the negative third. Yeah, so that's 16x to the negative sixth. Alright, and then plus, we have to multiply this item by each of these here. So to start with, we're going to have a negative 30x to the negative fourth, and then plus 24x to the negative sixth. Now we have to simplify where we can. So I'll shift back to red. Looks like we have x to the negative 6 and x to the negative sixth. So that's going to come out to be 40 x to the negative sixth. And then we'll have minus 30 x to the negative fourth. We can't leave it like that though. We're going to simplify it to this. 40 over x to the sixth minus 30 over x to the fourth.